All right, this is module 33, use similar polygons. So, first thing we have to go over is two polygons are going to be similar polygons if their corresponding or similar positioned angles are congruent. And the corresponding sides, similar positioned sides, are going to be proportional. The main thing you need to get from this is this notation here, this little tilde. It means similarity. So anytime you're comparing, for example, we had congruence, we had a symbol for congruence. This is the symbol for similarity. So I have my first diagram, and I tell you in the first part of it, I say that RST's triangle is similar to XYZ's triangle, which means that I can label all the congruent angles. And I can actually just look at the statement here and just kind of read off what the congruent angles are. So R is similarly positioned to X, so they're congruent. S is similarly positioned to Y, so those are congruent. And T is similarly positioned to Z, so those are going to be congruent. The next thing I have to do is check that the ratios of the corresponding side lengths are equal. So I have to check every single one of them. So RS's length is to XY's length, because if you look at the figure up here, RS and XY are positions 1 and 2. So positions 1 and 2, that means that you're going to write position 1, position 2. So once we do that, we write 20 over 12, which gives us 5 over 3. Then we do the exact same thing. We now need to do it with S and T and Y and Z. So S and T is 30, Y and Z is 18. And I'm reading it off the figure over here. So once I reduce that, I get 5 over 3. TR, that's the first and third position. First and third position in the next one would be XZ or ZX. Does not matter. You get 25 over 15 because they're in similar position parts. 5 over 3. Since we have all of the angles are congruent and all the sides are in proportion, have the same exact ratio, 5, 3, 5 thirds, 5 thirds, 5 thirds, you have to write the ratios of the corresponding side lengths in a statement of proportionality, which means that you have to write RS is to XY as ST is to YZ, as TR is to ZX. So all I'm basically doing is taking the ratios that I had here, ratio that I had here, ratio that I had here, and setting them all equal to each other, because all of their, when they reduce, all the corresponding sides reduce to 5 over 3. So all we do is just take the parts from part B and just make, this is called our statement of proportionality. And you need to know what a statement of proportionality is, because I'm going to be referring to it throughout this module and other modules as well. Okay, so given triangle JKL is similar to triangle PQR, list all pairs of congruent angles, write the ratios of the corresponding side lengths in a statement of proportionality. So this is exactly what we just did, only I give you its similarity statement. I don't give you a visual. So what you can do is just read off the corresponding positions. J is congruent to P, K is congruent to Q, L is congruent to R's angle. We also know that JK is a ratio to PQ because they're in similar positions, 1 and 2, 1 and 2. Do the exact same thing with KL to QR and LJ to RP. That's my statement of proportionality. Okay, so it says determine whether the polygons are similar. If they are, write a similarity statement and find the scale factor of ZYXW to FGHJ. So, if we are looking at this, what I see in terms of the labeling is that the angles, angle F is congruent to angle Z, angle J is congruent to angle W, angle G is congruent to angle Y, all based off of the labeling, and angle H is congruent to angle X. So, all that I need to do now is check to see if the actual sides, corresponding sides, are in proportion. So I start with 16 and 20, 12 and 15, 24 and 30, 20 to 25. And we see if all of those ratios are the same. So We identified the pairs of congruent angles, so the corresponding angles are congruent, so that's pretty easy. Next thing we need to do, show that the corresponding side lengths are in proportion. We started to actually do that, and you set up each proportion and see if they're all the same. Once you do that, I notice that all of them reduce to 5 over 4, 5 over 4, 5 over 4, and 5 over 4. So if they all reduce to the exact same thing, that means that these two are similar. So what you can say, since the ratios are equal, the corresponding side lengths are proportional, we can say that ZYXW is similar to FGHJ. The scale factor, not to be confused with scale, because remember scale has a denominator of 1. Scale factor is how do you go from one to the other, and that would be 5 to 4, because we just found that in this previous part here. Now the cool thing is about scale factor, you can actually use scale factor. For example, if I wanted to see what going from 16 to 20, well, I could say 16 times the scale factor is 5 over 4. If I did that, these guys would reduce, multiply that, you would get 20. That's how you can use the scale factor. And if we went the opposite direction from 30 to 24, you would have to do the reciprocal of the scale factor. For example, it would be 30 times, because we're getting smaller, 4 to 5. And we'll go into a little bit more depth into this, and that gives you 24 in a later part. So, it says in the diagram, triangle DEF is similar to triangle MNP. Find the value of x. So if we know that they're similar, we just use the corresponding side lengths to set up a proportion. They told us that it's similar, so that means we can actually do that. So, it doesn't matter which ones you pick. Pick the similar ones. You can pick MN to DE, and then NP to EF. The thing is, you have to pick the NP to EF because it contains the value x, which you're trying to find. But for the one on the left, you could have used 12 and 16 if you wanted to, respectively. But it's up to you. It really is. This is where the creativity comes in mathematics. So once I set up a proportion, I plug in the numbers that I know, and then you use your cross multiplication to solve. And you find out the value of x is 15. So that means that this missing part of the triangle, since they are in proportion, is going to be 15. Okay, another example. So in the diagram, they tell you that ABCD is similar to QRST. What is the scale factor of QRST to ABCD? Now, this is one of those things you need to be careful of. Answer is 1/2. Why is it 1/2? Because you need to start off with QRST, which is this guy, to ABCD, which is this guy. So you have to set up 8 is to 16, or 6 is to 12, or 4 is to X, or 5 is to 10. You have to set up and be consistent because we start with this one here first, and we end up here second. So this one has to go on top. This one here has to go on the bottom. Now, what if I asked to find the value of x? Using the scale factor, this is how this is kind of cool. So if we're going from the smaller one to the larger one, or from the larger one to the smaller one, it really doesn't matter. But you need to see, okay, I divide, for example, from here, from 16 to 8, I divide by 2, or I multiply by 1/2. So you can say 1/2 of x is equal to 4. If you solve, you multiply by a reciprocal, you get x is equal to 8. And that's it. So I found the value of x using scale factor. Okay, so another example. A town is building a new swimming pool. An Olympic pool is rectangular with length 50 meters and width 25 meters. The new pool will be similar in shape, but only 40 meters long. So it's a similar figure, but not the exact same. So, first thing I asked, find the scale factor of the new pool to an Olympic pool. So you have to take a corresponding side length to another corresponding side length, which would be, because the new pool will be similar to an Olympic pool, the scale factor is going to be the ratio of lengths, which would be the length 40 meters long to the length 50 meters long. So this is the old, the new, and this would be the Olympic to find the scale factor. And once you reduce that, you get a scale factor of 4 to 5. Again, do not confuse this with scale. With scale, you are actually having a denominator of 1, but scale factor can actually be used to find other parts as well. Okay, so now it asks, find the perimeter of an Olympic pool and the new pool. This one's a little more in-depth. So we know the perimeter of a rectangle is 2 times the length plus 2 times the width, and we plug it into the formula. We know our lengths and my widths, and you find out that it's 150 meters. So now, what you can do is you can set up a proportion. Since we know that x is to 150, because this is the new perimeter, to the Olympic perimeter on the bottom. Now it's saying use theorem 6.1. Well, what does that mean? What I'm basically doing is I'm using the scale factor. So this is the scale factor. In scale factor, that's going to be the exact same thing as ratio of corresponding side lengths or perimeter. So scale factor will be the same as perimeter in terms of a ratio. The ratios are equal. Okay. So, once we do this, once we set this up, cross multiply and solve, you get x is equal to 120. So that's going to be the perimeter of the new pool. Okay, so in the diagram, I tell you that A, B, C, D, E is similar to F, G, H, J, and K. It says first, find the scale factor of F, G, H, J, K to A, B, C, D, E. So that means since they give you an order to go based off of, you need to go from here to here. So this is top, this is bottom. So once you do that, it would be 3 to 2. How did I get that? Well, I take a corresponding part, like for example, FG is to AB. And I just do 15 is to 10. When I reduce it, I get 3 over 2. Now, using that, I can find the value of x. So it kind of depends on what way you want to go. If you notice, if you go from this way to this way, you're getting larger, so you can just multiply by the scale factor. So I can do 3 over 2 times x is going to give you the corresponding side to x, which is going to be 18. When you multiply by the reciprocal to get rid of the fraction, you're going to get x is equal to 12. Now it says find the perimeter, which means you're going to have to find the length of each one of the corresponding sides. So one of the things that I will tell you is I'm going to have you guys do on your own. We know that x is equal to 12. You have to find CD's length and you have to find ED's length. And I want to see if you understand the concept and come up with the answer 46, because you're trying to find the perimeter of A, B, C, D, and E. All right, so in the diagram, triangle TPR is going to be similar to XPZ's triangle. It says find the length of the altitude PS. Now this is a little more in depth because it gives you a corresponding side, a corresponding part to the figure that you have to find. So you have to set up a ratio that compares corresponding and similarly positioned parts. So here's the solution. It says first find the scale factor, and this is again one way of doing it. You could also set up a proportion, or you can use scale factor. So I'm going to use scale factor here. So I'm going to say that TR's length is to XZ's length because those are in similarly positioned parts. Once I do that, I get 12 to 16 and reduce it, I get 3/4. So that's my scale factor of TPR to XPZ. Now, I'm trying to find the length of PS. So what do I have to do? I have to actually write the proportion. PS is to PY, which equals the ratio, the scale factor that we just found. So this is our scale factor, and this is our corresponding altitudes here. Once we do that, then we can plug in what we know from the figure, and if you're still looking at the figure, we know that PY is 20. Then you just do cross multiplication and solve, and you get PS is equal to 15, which is the altitude length.